So we'll not turn this into too much of a training program, so repeat your due diligence. We can work with multiple materials simultaneously. That's what the colors are all about. That is a long time need that the industry has needed for some time now, to be able to work with multiple materials simultaneously. And here within the marking world, the nesting, material optimization, I've heard it called various things, we actually have all material types listed. And we'll enter into this workspace and we'll go ahead and just optimize this just to see what happens. You see the little tick marks in each little pattern component, I hope. Maybe if I have to enlarge this a bit, it may help those. Working on a smaller screen. These lines represent the grain line. Well, by default, we put those on the x-axis after we flatten them. And that's not exactly where they need to be. So how do I accommodate this? A couple ways. One, I have a rule of no rotation allowed on these parts. They're not allowed to move around. So that's why the yield is going to be just terrible. But sometimes that's what we have to work with. I'll stop this and we'll revert back to our marker view here, and I can either enter in, and I could even change the actual rule that's being used. Now this rule was pre-assigned in the database. Again, we talked about don't key it in data, so I did that in the database so I didn't have to, but it's not what I need for this job. But I don't want to change the database. No worries. This is only going to affect this job here. The database is permission controlled, so for the administrators out there, once you lock down your data, you're good to go. But you do allow flexibility for your users to make changes, whether it be piece gapping, edge buffering, or perhaps you got a sample piece, or it's an all-fall. It's not as big as the rest of them. You can even key in the actual size of the part you're actually working with. So this works for sheet nesting, as we call it. We refer to it as being a bound surface, because this could be a height, this could be, like I said, a 4x8 sheet, 5x5, who knows? But you do, so you can actually key in that information here. So I've changed the lay rule for this part. Let's see how it affects our optimization. Now the output of this nested file is a layered DXF file. And the layered DXF file then allows us to communicate with various different brands of fabric cutting equipment. We do not write NC code, so we're not going to feed a CNC lathe or router, if you will, but the DXF file could be utilized in those programs in a CAM format. But from the fabric world, the CAM part of the CAM function is actually being computed here, and then upon the exporting, which is here, we can actually then assign different layers to different functionality, because every brand of machine likes their information their way. Even though there is a standard, there's not a standard where everything has to be. It just has to be there. So this is actually just simply a DXF file that you can put wherever is necessary within your file management system, hopefully in a PDM program.